Okay, this is part 233, line 20E, how NASA creates nuclear fusion, sustained power UFO engine 5G Wow Seti. So I guess we're going to have a formula now. The Wow Seti alien radio signals there. I started Googling this May the 15th, and it looks like this started on May 16th for this one. May 16, 2012, my thoughts. I woke up this morning and heard the words, line 20 is nuclear fusion. The alien radio signal WOW, line 20's data is all about hydrogen splitting and gas particle test results. PDF files from theories and actual data. Both of these things are found in jet propulsion systems for NASA's and other countries' rocket and spaceships. So I did a Google search to see what is the current formulas or ideas that man uses to create nuclear fusion. Someone's comment on one of my videos told me that man has only achieved nuclear fusion to last for 2 minutes time. I decided to video blog my research on nuclear fusion and how it's achieved. I found that many of the formula's keywords are mentioned in the WOW lines of data. Amazing. It's like the puzzle pieces just started to make sense. An example of what the WOW signal is this. You open a box of puzzle pieces. They are randomly spread out around onto a table. You look at each piece and decide which section it goes to. Then you slowly put it together. It takes lots of time to do. It forms a big picture, and there it is. Now you know what the puzzle is. This project is exactly the same thing. Now we know why I had to do all the research on all the keywords to know what their meanings are. Because all the words mentioned in lines 17, 18, 19, and 20 in the WOW lines of data are also part of the formula ideas and theories that man uses to create nuclear fusion. What I'll do now is cross-reference the keywords from your formulas with the alien messages and formulas, and this should show us what is missing. Then you will add those keywords that are missing into your formulas, mixtures for gas, fuel, propulsion ideas, and see what you come up with. I'm assuming that this alien man astronaut is trying to teach us how to create sustained nuclear fusion in line 20's data. If it works, the scientific community will be working with the physics people and NASA to try it out in one of their missions. Hopefully they will blog the news that we can share in the joy of knowing this alien radio signal has helped mankind develop new alien technology. From my Google search for how to create nuclear fusion, I came across Ben Harrack's very informative blog. I'm going to pull keywords and phrases from Ben's research and use it to create a new formula of ideas for you. Ben also directs us to NASA's school website on thermodynamics and how they work in creating altitude and Mach number speed of sound for airplanes and jets. I've also got lots of PDF files, theories from scientists, along with the test results coming from 1967, 1979, 2002, 2006 students, and NASA's data files that are online. Take the formula ideas, piece them together, they will form a picture. It will show you the ability of this UFO engine's designs, propulsion speeds, and fuels required to travel from Earth to the Kepler-22b star region in less than 2 months' time. I think I mentioned this before and mistakenly said Mars. That is a goal to reach that planet in record time. The goal for UFO engine travel time is 3 days to go from the Milky Way solar system directly into the Kepler solar system or other parts of the universe. If you think it's impossible, then you need to see all the data video blogged. I started with 15 videos, and so far I'm up to 225 videos now. According to the ancient astronaut that sent this alien radio signal, WOW's binary coded data from 1977, a UFO engine can travel within 3 days from Earth to the Kepler-22b twin planet. This type of travel has been the holy grail for NASA and others who have tried tirelessly to achieve since the early 1900s. Most of the UFO sightings you see are secret government projects, testing to see how fast they can go and how far they can go. Most make it just before the moon and back in record time. Many are picked up in photos of the sun or on spacewalks and in orbit videos from the space station. They are reported as UFOs, unknown flying objects, because the public doesn't need to know top secret projects. Each government has strived over the past 50 or so years to outdo one another. This isn't what this UFO engine project is about. It's about creating unity with the world's scientists and physicists. Great minds, connected, can do greater things if they will work together as a team. True, I've seen cases through the data that several governments work as teams, and this is good. What I'm asking for is that all governments work together, sharing knowledge on this project. If you can think outside of the box and see yourselves traveling far distances in the universe, you can all share the burden of the expenses to create these kinds of spaceships, and you can each take different missions in various areas of the galaxy during your explorations. Thousands of galaxies to be discovered, lots of planets to be mined for natural resources, gems, stones, and other new foreign materials you've never seen before. Things that can be used to change technology as we see it. Earth's mental capacity is so limited by its lack of trust in itself. Look outside of what is the norm and see what you can come up with. Don't hold back those ideas in your mind. They will make sense someday, and shame on any of you that make fun of those that come up with the new ideas. Because of you, our knowledge here on Earth has been limited. If we embrace it and think maybe it's possible, then you will finally open up the mind to the alien technology that you see in the building of pyramids. Those designs, concepts will become a reality, and then you will understand it all. Don't limit yourself. Don't limit the power of the universe and what it has to offer you. Grasp its concepts. Figure out how to make it work. And do not ridicule anyone for having an idea that is outside the box of norm. If you do, then technology will slow down, and it will take us another 50 years to get to the next level of mental clarity. And most of all, you will no longer be living beings here on Earth. That would be a shame, the idea girl. May 16, 2012. Now let's look at the data I found on nuclear fusion, and my formula is from your data. I need the formula in order to compare my notes with yours. If I leave anything out, I need you to post a comment. Tell me what I should look for. A keyword, please. Thank you for your help with this project. I really appreciate it. The idea girl. Quotes to read. How can we create power from nuclear fusion? By Ben Harak. He put this on his blog on November 6, 2010. So as far as I'm concerned, that's pretty recent. What is nuclear fusion? Nuclear fusion refers to any process of interaction of two nuclei in which they combine to form a heavier nucleus. For light elements, this process typically emits particles such as other nuclei and neutrons along with a relatively large amount of energy. The reason we are interested in nuclear fusion for power production is that these reactions can release much more energy than is required to make them happen. A very simple analogy would be the combustion of wood. Energy is required to raise the heat of the wood high enough for it to ignite. Once we have ignited, however, it produces enough energy to keep itself burning and also release a lot of heat. And it's from visionoferth.org. May 16, 2012, my thoughts. I woke up this morning at 8 a.m. EDT and thought, what is line 20 telling us? And the word nuclear fusion popped into my head. Then it was like a lightning bolt hit me. Lines 17, 18, 19, and 20 all have words that are found in nuclear fusion. So I did a Google search to find out how we create nuclear fusion now and what we need to change so it will last longer than 2 minutes. My formula idea for nuclear sustained fusion. The splitting of hydrogen is used in fuels. The splitting of neutrinos with lepton and liquid argon gas formulas from lines 17, 18, and 19. So it's saying that we split the hydrogen, add a nuclei, plus combine nuclei, plus form heavier mass of nuclei, plus exploding particles, plus collider, plus add other particles, plus neutrinos, plus lepton, plus hydrogen, plus oxygen, plus H2, plus D2, plus large amounts of energy, plus relativistic jet particles from solar energy, plus dark matter, plus fermions, plus leptons, plus fire, plus heat, plus ignite equals sustained energy plus releases heat plus keeps burning. Now we have to go through the lines of data for these keywords and see what else you need to add to its formulas for it to work. I'll do this in another video. More data to look at now. I want to say a special thank you to Ben Harak for blogging about nuclear fusion. Your notes made it very clear on how it works. I am pulling out some of your quotes from your blog. I hope you don't mind. It's easier to show your research on the topic. This was part of Ben's final paper at university, so I'm assuming he's graduated by now and is working in his physics field. Also, a thank you to NASA for having websites up for students to learn from. Your data has been extremely helpful in figuring out this alien radio data stuff. And of course, to all of you for writing on Wikipedia all the definitions I've video blogged for the past 5 months. Thanks, the idea go. Quote to read from Ben Harak's blog. If someone is interested in digging into the underlying physics of fusion power, I've laid out some resources in the science behind fusion power. There's also a number of useful tools for understanding fusion power, and it's on visionoferth.org, okay? So you want to take a look at his blog to get the rest of the data. His concepts of what is needed in his physics final theory paper. Electromagnetism. This is the most important of the 4 fundamental forces for considerations of plasma containment. The Coulomb interaction is the basic fact that presents the barrier to fusion processes where the positively charged nuclei will repel one another. May 16, 2012, my thoughts. Keywords to look for in alien radio signal Wow Seti lines of data. 4 fundamental forces for considerations of plasma containment 2010. Based on what Ben Harak says, the keywords that stand out are plasma containment, 4 forces required for nuclear fusion, Coulomb interaction creates a barrier to fusion processes, how to remove the Coulomb interaction, electromagnetism. Ben Harak says, quote from his Vision of Earth blog, to understand the basics of fusion techniques, you need to understand Coulomb interaction and magnetostatics. Knowledge of electrodynamics and Faraday's law would be very helpful for understanding the tokamak. So the keywords are Coulomb interaction, magnetostatics, electrodynamics, electromagnetism, Faraday's law. Sorry, I'm going to make a note here. So I'm going to go back to this video. Tokamak, atomic nucleus, nuclear physics, Ernest Rutherford, thermodynamics, plasma containment, 4 forces to create nuclear fusion. Quote from Ben Harak's blog, Carnot engine and the second law of thermodynamics. These 2 concepts are very important, but they are only a tiny portion of the areas of thermodynamics that are directly relevant to nuclear fusion. Key words, Carnot engine, law of thermodynamics, nuclear fusion, thermodynamics by Enrico Fermi, fermion, plasma physics, and ignition state. Plasma physics depends on exceedingly good knowledge of electromagnetism and thermodynamics. Also, it is good to know some statistical mechanics as well. Ignition state. Ignition state occurs when enough fusion energy is being created in the fusion plasma that the amount of the energy kept in the plasma is enough to continue causing the current rate of fusion. Another way to look at it is that there is enough energy kept in the plasma to maintain fusion conditions. Lawson criterion, first described by John D. Lawson in 1957. It is a measure of the minimal conditions required for achieving ignition in a plasma. We can think of this value as the relative difficulty of achieving ignition of a fuel plasma. The Lawson criterion is an inequality demonstrating that the product of electron density Ne and energy confinement Te must be greater than a quantity L, called L, in order for ignition to be possible. The value of L depends on a number of factors which we will go into shortly. For instance, at the temperature of 25 keV, L has the following value for the DT reaction, the deuterium-tritonium fusion process. And there's the equation there. This means that in order for an ignition state to happen, the product on the left has to be greater than the value on the right. The value on the right in this equation is L. So there's the equation there. So where Kb is the Boltzmann constant, ECH is the energy of the charged products per fusion reaction. T is the temperature of the ions, O is the fusion cross-section, and V is the relative velocity of the ions. Never seen the EV unit before? It is an electron volt, a unit of energy that is very useful when studying nuclear interactions. And then I have a graph here. A picture is useful here to illustrate how the L value changes with temperature. This picture is for DT, deuterium, tritonium fusion process. As you can see, for DT, the L function has a minimum around 25 keV. This means that the conditions of fusion are most easily attained for DT around a temperature of 25 keV. Again, that's from Ben Harrack's blog, Vision of Earth. This is the link to NASA. What is thermodynamics? Glenn Research Center. Thermodynamics is the study of the effects of work, heat, and energy on a system. Thermodynamics is only concerned with large-scale observations. Zeroth law, thermodynamic equilibrium, and temperature. First law, work, heat, and energy. Second law, entropy. Keywords, quotes, or phrases from the NASA blog. Small-scale gas interactions are described by the kinetic theory of gases. There are three principal laws of thermodynamics which are described on separate slides. Each law leads to the definition of thermodynamic properties which help us to understand and predict the operation of a physical system. We are most interested in thermodynamics in the study of propulsion systems and high-speed flows. Many of the classical examples of thermodynamics involve gas dynamics. The zeroth law of thermodynamics involves some simple definitions of thermodynamic equilibrium. Thermodynamic equilibrium leads to this large-scale definition of temperature, as opposed to the small-scale definition related to the kinetic energy of the molecules. The first law of thermodynamics relates the various forms of kinetic and potential energy in a system to the work which a system can perform and to the transfer of heat. This law is sometimes taken as the definition of internal energy and introduces an additional state variable, enthalpy. The first law of thermodynamics allows for many possible states of a system to exist, but experience indicates that only certain states occur. This leads to the second law of thermodynamics and the definition of another state variable called entropy. The second law stipulates that the total entropy of a system plus its environment cannot decrease. It can remain constant for a reversible process, but must always increase for an irreversible process. Key phrase here is the first law of thermodynamics relates the various forms of kinetic and potential energy in a system to the work which a system can perform and to the transfer of heat. The law is sometimes taken as a definition of internal energy. So a formula is kinetic plus energy plus thermodynamics plus transfer of heat plus internal energy needs to be created to achieve nuclear fusion. Here's a thermodynamic equilibrium graph. 1, 2, and number 1. So when two objects are separately in thermodynamic equilibrium, with a third object they are in equilibrium with each other. Objects in thermodynamic equilibrium have the same temperature. The key word is three objects plus same temperature equals thermodynamic equilibrium. Thermodynamic equilibrium is in the Wow Seti data in line 17 and 18's formulas. Thermodynamic equilibrium, when two objects are separately in thermodynamic equilibrium with the third object, they are in equilibrium with each other. And they have the same temperature. There's the gas temperature graph. I'm not going to read all this. So, similarity parameters, stickiness, springiness, aerodynamic forces depend on RE and M, Reynolds number and Mach number. As an object moves through the atmosphere, the gas molecules of the atmosphere near the object are disturbed and move around the object. Aerodynamic forces are generated between the gas and the object. The magnitude of these forces depend on the shape of the object, the speed of the object, and the mass of the gas going by the object, and on two other important properties of the gas, the viscosity or stickiness of the gas, the incompressibility of springiness of the gas. Aerodynamic forces depend in a complex way on the viscosity of the gas. As an object moves through a gas, the gas molecules stick to the surface. This creates a layer of air near the surface called a boundary layer, which in effect changes the shape of the object. The flow of gas reacts to the edge of the boundary layer as if it was the physical surface of the object. To make things more confusing, the boundary layer may separate from the body and create an effective shape much different from the physical shape. And to make it even more confusing, the flow conditions in and near the boundary layer are often unsteady, changing in time. The boundary layer is very important in determining the drag of an object. To determine and predict these conditions, aerodynamicists rely on wind tunnel testing and very sophisticated computer analysis. The important similarity parameter for viscosity is the Reynolds number. The Reynolds number expresses the ratio of inertial resistance to change or motion, forces to viscous, heavy and gluey forces. From a detailed analysis of the momentum conservation equation, the inertial forces are characterized by the product of the density r times the velocity v times the gradient of the velocity dv dx. The viscous forces are characterized by the viscosity coefficient mu times the second gradient of the velocity d2 dx2. The Reynolds number RE then becomes this. Where L is some characteristic length of the problem, if the Reynolds number of the experiment and flight are close, then we properly model the effects of the viscous forces relative to the inertial forces. If they are very different, we do not correctly model the physics of the real problem and predict incorrect levels of the aerodynamics forces. Aerodynamic forces also depend in a complex way on the compressibility of the gas. As an object moves through the gas molecules move around the object. If the object passes at a low speed, less than 200 miles per hour, the density of the fluid remains constant. But for high speed, some of the energy of the object goes into compressing the fluid and changing the density, which alters the amount of resulting force on the object. This effect becomes more important as speed increases near and beyond the speed of sound, about 330 miles per second or 700 miles per hour on Earth. Shock waves are produced that affect the lift and drag of the object. Again, aerodynamics rely on wind tunnel testing and sophisticated computer analysis to predict these conditions. The important similarity parameter for compressibility is the Mach number m, the ratio of the velocity of the object, the speed of sound a. M equals v divided by a. The Mach number appears as a scaling parameter in many of the equations for compressible flows, shock waves, and expansions. When wind tunnel testing, you must closely match the Mach number between the experiment and flight conditions. It is completely incorrect to measure a drag coefficient at some low speed, say 200 miles per hour, and apply that drag coefficient at twice the speed of sound, approximately 1400 miles per hour. Mach equals 2.0. The compressibility of the air alters the important physics between the two cases. Here's a Java program to calculate the Mach number and Reynolds number for different altitude, speed, and length scales. So you can find the calculator at www.grc.nasa.gov. The effects of compressibility and viscosity on lift are contained in the lift coefficient, and the effects on drag are contained in the drag coefficient. For propulsion systems, compressibility affects the amount of mass that can pass through an engine and the amount of thrust generated by a rocket or turbine engine nozzle. So that's from 2009. And there's the different things that you can get from there. And Tom Benson's the guy that wrote it. Here's a graph here showing how it lifts and stuff. So May 16, 2012, I have never understood what makes a plane fly. This is important to know for the UFO to fly. We need to understand how an airplane or jet flies. Quote from NASA blog, as a wing moves through the air, the wing is inclined to the flight direction at some angle. The angle between the chord line and the flight direction is called the angle of attack and has a large effect on the lift generated by a wing. When an airplane takes off, the pilot applies as much thrust as possible to make the airplane roll along the runway. Just before lifting off, the pilot rotates the aircraft. The nose of the airplane rises, increasing the angle of attack and producing an increased lift needed for takeoff. The magnitude of the lift generated by an object depends on the shape of the object and how it moves through the air. For thin airfoils, the lift is directly proportional to the angle of attack for small angles within 0 plus minus 10 degrees. For higher angles, however, the dependence is quite complex. As an object moves through the air, air molecules stick to the surface. This creates a layer of air near the surface called a boundary layer that in effect changes the shape of the object. The flow turning reacts to the edge of the boundary layer, Just as it would to the physical surface of the object, to make things more confusing, the boundary layer may lift off or separate from the body and create an effective shape much different from the physical shape. The separation of the boundary layer explains why aircraft wings will abruptly lose lift at high angles to the flow. This condition is called a wing stall. That's from www.grc.nasa.gov. May 16th, my thoughts. Ben Harrach mentions deuterium-tritium fusion process, and this was mentioned in previous WOW SETI data. Keywords found in lines 17, 18, 19, 20 of WOW data. L function equals Lawson criterion. Fusion attained by DT temperature 25 keV. Boltzmann constant, fusion reactant, temperature of ions, fusion cross sections, velocity of the ions, plasma containment, PDF inventions, patents, and test results are in the data, electron volt, ignition state. To do, we will have to do a cross-reference of these keywords in WOW data to see what comes up. All have been covered in lines 17, 18, 19, 20 of the WOW SETI data. Keywords from data found on Ben Harrach's Vision of Earth blog and NASA Thermodynamics blog. Column interaction, magnostatics, electrodynamics, electromagnetism, Faraday's law, tokamak, atomic nucleus, nuclear physics, Ernest Rutherford, thermodynamics, plasma containment, four forces to create nuclear fusion. Carnot engine, law of thermodynamics, nuclear fusion, thermodynamics by Enrico Fermion, plasma physics, ignition state, NASA Glenn Research Center, Tom Benson. Reynolds number, Mach number, object speed, speed of sound. Propulsion systems, lift coefficient, drag coefficient, mass, thrust, nozzle, altitudes, compression of air, physics, aerodynamic forces, momentum conservation equation, wind tunnel, viscosity of gas, boundary layer, and flight conditions. So when we do the cross-referencing, we're going to be looking up all those words. Okay? This was a long one. Sorry about that.